Yeah, so basically today we're going to do basics of scripting, and it's going to be a little intro to programming, and you're going to write your first line of code. And then we're going to do fun things like input events, moving transforms with scripts, how game objects talk to each other, learning how to debug, how to use the script reference. Those are really important because I'm going to try to teach you not so much memorization and like you have to remember this and copy and paste that, but like I'm going to teach you where to find the stuff online and how to copy it and write. Because like I said, like I've been doing this for like 5 years now, and I still go to the script reference and I copy and paste it because literally it's easier than just trying to remember it and doing it all. But after doing enough of that, eventually you'll start to remember a lot of them. Like I remember a lot of them now. But yeah, and then towards the end, I'm going to introduce you to the music package that I wrote that lets you make music reactive environments. And then I'm going to get you set up to do the homework for the week, which is going to be create your own VR music video.
Nice.
So yeah. So yeah, the first thing that I want to start with is yeah. So the first thing that I want to start with is just a little whiteboard here. We're just going to talk about programming a little bit. So, we're still working from this game object. Now remember how we had each game object has a component, right? That's how we show that those, this one sucks. All those things on the right side in the inspector, they're all like components. And the component, each game object has its transform, which is also technically a component. Now, all the components and stuff that comes with Unity, like the camera, the lights, the rigid body component, the box collider component, all those things come as part of the Unity environment, basically. They're already kind of written codes and they're kind of embedded. The reason is obvious. It's just kind of like there's only really one or two good ways to write those kinds of things, and for most developers you don't need to know how to write a physics engine from scratch. You just don't. You just want to put a rigid body on and it works. Whereas back in the day, if you wanted to be a game developer, if you went to even today, if you go to a game design school, or if you do, if you go to like any kind of programming school, they will teach you the raw OpenGL, DirectX way of doing things. And what those things are basically is, so you have, those are the two major graphics platforms. You have DirectX and OpenGL. Now, DirectX is all Windows, Xbox, all the Windows machines and stuff. OpenGL used to be not as popular as DirectX, but with the coming out of Android and iOS and stuff, everything is kind of powered by OpenGL and the mobile OpenGL version, basically. So OpenGL open source, DirectX closed source, Microsoft only. And that was kind of like the reason why Android and a lot of these other companies like Apple went for OpenGL, because it's a well-developed graphics framework. Now, what these things actually do is they're the stuff that actually renders the pixels on the screen as 3D objects, as cubes, and etc. So like when you're doing programming, you're basically you're not going to have to worry about this stuff like people used to, because Unity basically abstracted all of these kinds of functions in the Unity engine, and when you export to all those different platforms, it knows which platform to pick, and you could even set the settings yourself and pick like a specific version of OpenGL, or if you have an old phone or a new phone, it has everything kind of in there. And what basically happens is when you write lines of code, which is kind of closer to the English language, you write something like if, and then something in here, if you know, x is equal to 1, you know, then, I don't know, like, you know, y is equal to 2. Or instead, you know, maybe something more reasonable, something like if, you know, if left mouse is true, or something like that, left mouse button is equal to true, then, you know, explode or something, right? And these are abstractions that you would write. But basically, when you write code, you write it in the English language. And then what happens is this code goes through something called a compiler. So a compiler converts all this English language, like human readable stuff, into zeros and ones. The stuff that we just can't understand. But it goes through a compiler, and that's what the machine understands at the end of the day. Now, all this stuff, the DirectX, OpenGL and stuff, those were also very kind of closer to English language, and they went through their own compilers and stuff. But yeah, basically, in Unity, you have everything built in. You have the graphics engine, you have the compiler, you have the scripting, you have everything. So you really never have to pretty much leave Unity to build your program, unless you're doing art. Because Unity is not so much of an art package as much as it is something called an integrated development environment, an IDE. You might have heard that term before. But yeah, it's integrated development environment. Now, without getting too deep into all these terms and stuff, it's just good to kind of know, but that's what you're working with. And so now I'm going to go to something that you might, you know, more recognize. So back to these components and transforms, right? So a script, when you write it in Unity, works like a component most of the time. Not all the time. Sometimes scripts don't even exist in the 3D world. They're just outside of it. But for all intents and purposes, for what we're doing and for most uses in Unity, everything that you write as a script basically attaches to some game object and then affects the behavior of that game object. It moves it, it changes its color based on some conditions. So when you write code, you write lines. So everything kind of goes in, you know, you got your one line of code and another line of code and another line of code and so on and so forth. So what the CPU does is when it compiles things, each line of code runs sequentially. So first runs one line, then another line, then another line. For all intents and purposes, that's how most programming is done. There is such a thing as multi-threaded programming, where like there's simultaneously multiple lines of code working at the same time. That's a lot more complex because the reason is the CPU doesn't know what's happening in between these. So this core that has no idea what's happening on this one. So there has to be these abstractions of sharing data at the endpoints, and that's just like way beyond most people's head, even beyond mine. I don't really play with multi-threading too much. But Unity optimizes a lot of this stuff for you. So the reason why I'm explaining this is because you'll see when we start writing code, it's going to be very simple stuff. But basically, as it goes through the lines of code, when it reaches the end, and there's conditions and stuff in between here, it just starts right back at the beginning, and then it goes through that again. So the CPU is always kind of just checking. So here you'll have some if statements, and basically it'll keep checking if those are true. And once they become true, it'll run that, and then it'll just keep going back there. So when you write things, it's always written there. It's you that chooses when it gets activated and when not. But it's not like, it's basically like, it just kind of runs through the whole list, always. So the most important thing in Unity specifically, and you'll see this when we start our first script, is you're going to have something that says start, and then there's like a curly bracket here, and expects you to write some stuff here, and update. So what this means is that anything you write on start runs once. It runs once, when the game or that object gets created, it has the script, and it's done. This all these lines of code. Whereas update runs, like I said earlier, just on update, so it's always looping.
How long does it take to loop?
It's almost instantaneous because it's super fast. But you'll see how we'll actually work that, and to our advantage.
Is that updating per frame? Or?
Yeah, it's basically it's like even faster, like
Okay.
the code. It just, yeah.
Cool.
But yeah, the graphics and stuff runs per frame. So yeah, I mean, that's just kind of like the very basics of it. The other thing that I like to explain too, and some people might not know this, and I personally learned it and I found it fascinating. When you work with 3D, and all this stuff is taken care of for you now, so you don't have to worry about it, but it's just good to know. A 3D object, like a cube, for example, only exists really as mathematical points on the computer. There's like a point for each one, and it says this is like at this location, this is at this location, etc. And then there's these triangles that, basically everything is a polygon. It has three sides. It has 3 points, and then they connect and they create a face, and then that's how you create these 3D objects. But in the CPU, they're all stored, and when you're running your code and stuff, everything is kind of like infinite detail. So a line is just like, it's a perfect, like kind of like formula of a line. Whereas when this actually gets rendered on your screen, what the computer tries to do is it tries to fit this picture and the angle that the camera is shooting from. So this is like, let's say, our camera view, something like that. So it tries to fit this into pixels. So then this line ends up looking more like this in reality when you're rasterizing. That's why sometimes you see things get pixelated. That's what people call it, pixelated. So basically the computer, this is the only way it can actually draw, and this is something called rasterization. So it's all done automatically for you, but this is kind of where the magic happens. So this, which is just kind of like an abstract shape, gets actually converted into something on your monitor. Like each pixel gets colored in, and that's where like the performance stuff comes in. Where like if you have way too much like geometry and stuff, even though it's not all showing up on screen, a lot of times things can be behind other things, and just the computer doesn't know, and it'll still try to render layer on top of layer, even though maybe something's not visible here. In reality, it drew it behind there, and then it drew over it and over it and over it until it got to what it needs. But yeah, this is just basic computer science stuff. You don't need to remember any of this, honestly. It's just a little fun tidbit. If you can kind of get like that 3D objects are actually just kind of like mathematical formulas and locations, whereas at the end of the day what happens is the graphics card converts that into a 2D plane, and it rasterizes it into pixels basically. And that's where sometimes a lot of that magic happens when you start writing shaders and stuff, is you're actually tweaking that end result and tweaking its colors, and sometimes you can do some pretty advanced effects without wasting CPU, because it's down the pipeline. So the CPU already kind of has the same geometry and stuff, but at the end of the day, all the shaders and stuff kind of happen in post, if you could say, kind of. But yeah, so, and some effects are achievable like that, some aren't. But yeah, I mean, without further ado, I would say just open up Unity, and I will kind of show you just the simplest thing to start with. And we can open up the same project that we were doing yesterday too. Okay. So the first thing that we're just gonna do is we're gonna write like our first line of code, just basically like a classic hello world program. So to create a script, and the scripting language that I'm going to be teaching you that I recommend everyone use in Unity is C#. So you're going to right click here in the project when you have Unity open and create C# script. It's right at the top there. And name that, something like hello world. Once you have that, double click it and it should open up your scripting program. Now if you're on Windows and it doesn't open the same one that I have, MonoDevelop, if it opens Visual Studio, I can show you how to change it to this.
My editing come up. Maybe something else.
Well, yeah, that's it. It's just a scene probably. You should look at, because we saved 2 scenes, remember?
Oh, okay.
Just check in assets, the top level. Yeah, click one of the scenes. Just double click it. Yeah, there you go.
Alright. Sorry, I'll wait for a minute.
So just in the project, create a new script. So just right click, create C# script. So this is where you pretty much create all your assets that you work with. And once you have that, you double click the script and it will open up your scripting engine. And I want to see which one is going to open for you. Yep. So I will switch you out of that.
Okay.
So the way that you switch that is just, you can turn it off when it turns on, but go back to Unity and go to Edit, Preferences. This is just for Windows. You probably have Mono, no Mac. So just Edit, Preferences. It's okay. Okay, just Alt-Tab. It'll do it. So yeah. So go to where it says File, Edit. Just click Edit Preferences, and then External Tools, right here. And then it should say, external script editor right there. So switch that to Mono, yep. And then just close that. And now go back and then open your script again. And it should open Mono. I just prefer Mono. I'm sure Visual Studio is great. I just don't have the experience in it, so I can't say if something goes wrong what to do with it. But it's pretty much the same thing, I think. So you'll see something like this, right? Now all this up here, using system collections generic, using Unity engine, you don't have to worry about any of that. That is basically something called libraries. So these are the basic libraries that Unity just kind of puts in there for you right away, and it lets you start to work with things within Unity. You will probably never have to change that. Only in very advanced programming cases will you probably have to add more up there. But for this pretty much the entirety of this bootcamp, we probably will not need to add any libraries or anything like that. So for the most part, you should you never really have to look at this up here. What you want to look at is everything inside this, the public class hello world. Now you'll notice that it automatically generates all this. So the name of your script is the same as the name of the class, and it has to be. The moment that you change the name of your script here to something else, it will probably give you some sort of error, and it will say, like, when you try to use it, it will say that the name of the class isn't the same as the name of the file. So just keep that in mind. Like if you ever create a new script and you don't like the name of it, and you just rename it because you're like, I want to keep it clean, and then you get some error, just make sure that the name of the file is exactly the name of the class in here. It just does it automatically for you, but I've seen people sometimes rename their script and then be confused as to what happened. So basically you'll see public class mono behavior. Now what is mono behavior? So mono behavior and mono develop is basically the scripting engine that Unity runs in. So not only is it just C#, but there's a library built on top of C# called Mono, and this existed even before Unity. So mono, not the disease. I feel like I've done this before. So it's basically a cross-platform integrated development environment. They used it because it's very simple to compile from this to all the platforms, to mobile, to everything. So Unity really, like in its core, uses Mono, which is an open source framework. So just so you know what Mono means, so you're not like, you know, kind of like, oh, I have no idea what Mono is. It's just there. But basically, all your scripts are going to be in these types of things, like public class, the name of your script, and then Mono. This is all automatically always written for you. You never have to touch this, but just as long as you know what this is. So everything in scripting happens inside these kinds of curly brackets. So the curly brackets, you notice that they open and they close. So that makes it kind of like become one chunk. So anything that's in between, so when it says public class and then there's a curly bracket there, that means that everything inside that curly brackets, those curly brackets, is part of that class, basically. And the same goes for these start and update functions. So anything that you want to run on start would be between these curly brackets. Anything you want to run on update would be between these curly brackets. And it even gives you this little comment right here. It says use this for initialization. So I mean, let's explain that first. So in coding, you have things that actually get processed as code, the stuff that's in color. The stuff that's grayed out are comments. So an easy way to write comments is you just do this like // and then hello, this is a comment, you know. And people use this to comment their code and to kind of explain it, whether for other people or for yourself later down the line if you forget what you were doing. Another way of doing these comments is to do a / and then a star, and then everything that's inside that star, and then you have to do another star and / to, and then you can do a whole paragraph of comments basically. So if you ever see that, that's what that means. But yeah, without further ado, let's explain what this void means, right? So void might sound like a scary or confusing word or whatever. It's basically the synonym of function in any other programming language or just regular things. And what that basically means is it's kind of like where something runs and gets executed in the program. So Unity has some built-in functions like start and update, and there's other ones like void on collision and stuff like that. And basically they run on specified times in the program. Again, don't let any of this bog down your head at all. You really don't need any of this. Just kind of explaining what it means so that it doesn't confuse you. And I'll explain later why specifically it's void and not function or something like that. It's just a C language thing. It basically means there's no return. It just runs and it doesn't expect a result. It just runs. That's why it's called void. But you'll understand why it means void in a little bit. So the first thing that we want to do, right, is I want to just echo something to the log, just like in code. So we want to just write a simple hello world, right? So here's how we're going to do that. So here in start, I want you to look right between these curly brackets, get your mouse and keyboard ready, and type with me like this. Type debug dot and then capital L log, just like that. And then you open a parentheses, and then you put a quotation mark, and you write hello world. And you close the quotation mark, you close the parentheses, and then to finish your line, you do a semicolon like that. And that's it. And now you save. Okay? So you go back to your program. Now I want you to click, see where it says project right here in your project view? Just click the console tab right here. So the console tab is where all your errors and information and stuff comes up as messages for your program. So if you press play right now, nothing will happen. Your console will stay empty besides what's happening in your scene. Now the reason is because we did not attach our hello world script to the world yet.
I get an error, unexpected open bracket.
So let's see. So I think you have like an extra yeah, it's parentheses here. So the curly brackets and parentheses, they're used in special situations, yeah, but when you're doing for this specific one, yeah, you're doing a parentheses. And you'll see why in a little bit. So yeah, it will not show up your message because this script, the C# script, is currently not attached to any game object. So just for the fun of it, let's take that script and like grab your plane, for example, or any other object you want. It really doesn't matter. Main camera is fine too, but let's do it on the plane so we all do it the same. Then take this script and just drag it onto the name plane in the hierarchy. You can also drag scripts onto the 3D itself, but that I don't recommend that because that could be messy and you might not know where your script actually landed. So all you do is you take the script like this and you just put it on an object like that. Boom. So you'll notice that your object, if you have it selected, now it has this little hello world script here in the corner as a component. You see that?
Can't add script component. Hello world.
So let's see. Did you save the changes that you made earlier? So let's see. Go back. Oh, so you did the same thing. So you saved it as new behavior script, but then you renamed it to hello world. Remember what I was saying? So just rename the class to the same as your file. So hello world, and then it should work. A quick way of selecting the whole thing is you just double tap the whole piece of text.
Oh, okay.
Too. Yeah, so just that, save, and now try to attach it again. It won't let you attach until your script is actually proper and working.
Cool.
So just do that. Yeah, and then you should see it pop up as a component, notice, right? So now if you press play and you click the console, it should say hello world right there. And that's the simplest form of, yeah, so just click the console.
Where?
It's right next to the project tab. It also shows up there in the bottom as well, the most recent message.
Cool.
So this is like called a debug log. So a lot of times you use this if you just want to just output some text from the program. Maybe you want to output the position of something or the number of something or whatever, just for yourself to see as a programmer. And like I said, one quick way to find these is they always show up right here. Like the latest message just shows up there, whether it's an error or an informational. Errors are usually red, warnings are usually yellow, and like when they're white, that's just the info thing, which is no problemo. So that's basically like the simplest form of output. Now what we're gonna do, right? So I'm gonna teach you how to do just a simple if statement. Just like if something is true, then we're gonna do the same thing, like debug something that you want, right? So now input is usually done on update, or pretty much all the time is done on update. Now the reason is because we're always checking for the input. We're checking if a mouse button is clicked or something like that. So we're gonna do specifically mouse click left. So this is how you do it, right? So you go into update right here in between the update curly brackets and type with me, right? So you type if, and then you open a regular parentheses, and then in there you write input with a capital I, and you'll notice that it kind of gets you to autocomplete. Those are super useful. And then just type period, like dot, and then get, and you'll see it'll show you all these little get button, get key, get mouse, and then you see it auto completes already to get mouse button, get mouse button down, and get mouse button up. So it's like there's all these different conditions. So you can fire it when the mouse is released, when the mouse is pressed, or when the mouse is held. If you do just get mouse button, pretty much as long as you're holding it, it's true and it will just keep firing that event. We want just on get mouse button down. So that's just on the initial click. And if you keep holding it, it doesn't matter. It's just on the down event. And you can let it autocomplete for you by just literally just, you know, if you're just doing if you're typing it and it already kind of says what you want there, you can just double click that and it'll autocomplete it for you. Then you open another parentheses, a regular parentheses, and then it expects which mouse button. Now you'll see here it kind of shows, you know, what it expects to get in there. So it kind of shows you the structure. I want a parentheses here and I want to close it, and I'm expecting an int button. So int is an integer. There's a few of these what are called types in programming that you're going to encounter. There's things like text. There's things like, you know, integers, like numbers, like 1, 2, 3, 4, 5. And then there's floating point, which are more like decimal numbers. So decimals aren't integers, right? Just like basic, you know, school math that we did a long time ago. So there are specific types, but specifically here, it expects like whether left mouse button is 0, right mouse button is 1, and then the other ones are 3, 4, I don't know which ones they are. But since we want the left mouse button, we're just going to put 0 right there. So in the parentheses put 0, then close that parentheses, and I'll check it. So this parentheses that we just closed is for this thing, right? So this says open and close. Now it also expects us to close this if one, because that's basically another one. So just close it again, like that. And then open a curly bracket, and then make a few lines with enter, like that. Just give yourself some space, and then close the curly bracket. And it should look just like that. Okay? So now, everything that happens between these curly brackets belongs to this if statement. So, same thing how everything that happens between these curly brackets belongs to this function. Everything that happens between these curly brackets belongs to this statement. So, that's kind of the difference between the curly brackets and the regular parentheses. Parentheses kind of expects a value, where the curly brackets expect statements. It expects multiple kind of possibly functions like this. So again, don't let it the words functions and statements get over your head. We'll kind of explain it. But right now,
the curly bracket is going to be the then.
Basically, it's then, yeah. But like basically everything in there is kind of like
Cool.
Then. So we're just gonna copy and paste the same exact code that we have in start right here.
Yep.
Just copy that and put it there, and you can change that text to anything you want, like mouse was clicked or anything you want. Okay, I don't got that. It's okay. Alright, so now if we go back to our program and we press play, I want you to open up the console again and click here in the game view where like your actual game is. That's where it expects input, and just click and see the events start firing, or your mouse was clicked. Now you might see that this number is increasing over here. Now, oh, oops, I'm sorry. It's supposed to be get mouse button down. I did get mouse button, so every time I was holding it, it fired it. But it'll still work.
What do you
now,
mean by holding it?
So, see, like, if I do, let me just put this back to how it was, right? So, check it out. So here, it's collapsing all of the duplicated messages when you have collapse on. So it won't show you the same message. Instead, it will just kind of like increase it here. But check it. If I don't have collapse and I hold, see, it's it's doing that.
Yeah.
But instead, what we actually want is we want mouse button down, because we only want it to fire once. I don't know, did you all put get mouse button down?
Yeah.
It is? Okay. And then back in your program, just turn off this collapse here. You should see it here in the console. And then every time you click, you should see a message pop up.
Yeah.
Everyone got that? So you have to click in the game view. Hmm?
Drop is a little low too. Can't add script.
So it must be a little script error.
Not be found. So I updated that. Maybe we do it again.
Let me see. So you have seems good.
'Cause,
Oh, it might be you renamed it. So hello world is one line here, whereas your script name is. So I would recommend you always keep it together.
okay.
Yeah, and just rename the script exactly the same as the class name. Yep, that's why I said it could not be found. Just give it a sec. Yep, and then now just if you press play. Yep. So it's the collapse.
Yeah.
Yeah, that's why. But see, it's incrementing the number there. So either way, it's your preference whether you want to just see them like that or it collapsed. Collapsed is usually better if you have just shit tons of messages coming in.
Yeah.
So that's like the most basic event, basically. So you had a simple if statement, and what we're actually checking is if the mouse button clicked is equal to true. Now, here's the thing, right? So this input get mouse button. Now I'm just gonna show you this. You don't have to copy this, but check it out. If you just type it input get mouse button down, it's a public static bool. So the public static stuff is not that important. What's important is that it's a bool. So let me explain really quick what these are, right? So you have a few of these basic types, and that's all there is pretty much to programming. You have these bools, strings, integers, int, and floats. That's pretty much all the ones you're going to use. Bool is true or false. That's basically a 1 or a 0. That's the simplest form of just true and false. Strings are everything that you write in between these quotation marks. So that's like that text that you wrote, hello world. So that's a string. Integers are numbers like 1, 2, 3, 4, 5. And floats are basically decimal points. 1, 2, 3, 4. That's kind of like those really precise, like X, Y, and Z. Like when you move them, it's never in increments like that. It's more precision. It's like down to a smaller decimal. So in programming, it'll always show you there in those autocompletes and stuff. And when you're looking up these functions, it'll basically tell you, I'm expecting that kind of value, and I'm giving you that kind of value. So what it means is when this says bool in front of it, it basically means that it's returning true or false. So on get mouse button down, it's true or false. So we basically did it in like a short way. If input get mouse button down 0, this is actually the equivalent to if input get mouse button is equal to true. It's the same exact thing. The program interprets it as the same, because when you just give it a true or a false in an if statement, you don't actually have to say is equal to true. It just kind of assumes that you're just expecting the true. Again, don't let...
If you want it false, you'd have to specify that.
Yeah, so you write it like that, false. A quick way of doing it without writing the false, you don't have to remember this, but it just, so you know, is people just put a question, exclamation point behind it, and that basically means if it's false.
Gotcha.
So now you'll notice that if I press play, it'll keep firing that message until I actually click it. Then that one time it doesn't fire it. You get what I mean? Because it's literally you checking for the opposite. So we'll revisit like the bool, strings, ints, and floats in a second. But now what I want you to do is I want to explore this area outside of this start and this update. And most of the time what you're going to use that for is for something called public variables. So public variables are basically let me explain what a variable is first of all. A variable is just like how we had back in school, x and y, solve for x. So you have like, x could be anything. It could be 5, it could be 10. In programming, x can also be letters. It could be like a string. It could be a whole paragraph, it could be a whole book. Variables are basically placeholders for information. So in this instance, what I'm going to do is I'm going to actually make a placeholder for this text field. So just right up here, outside of start, doesn't matter where, you could, as long as it's inside this class and outside of one of these voids, you're going to write public, just like how I'm doing right there, public string, and then is equal to, and then you write, public string, and then my text, something like that, is equal to, and then quotation mark. Always put a space between the equal, like that. And then quotation mark, and then just write something like mouse was clicked, or whatever you want. Close the quotation mark, and then a semicolon to end that line. So now let me explain what we did, right? So now we're storing this piece of text, mouse was clicked, inside a variable called my text, right? So here's how you can use that. So down here in our little code that we wrote, if input get mouse button down 0, debug log. Now I want you to replace where it says mouse was clicked here and just type my text, like that. So that's basically the exact same thing. Instead, but it's a much cleaner way of doing it. So you're referencing the variable my text, which could be anything, and that will get displayed once you click the mouse button, right? Now,
what's the value of doing that?
So let me explain, right? So if we go back to our program, if we click, we'll see, click, click, click. It does the same thing, but the difference is, check your component, right? Notice my text is now exposed to Unity right there, and it says mouse was clicked, right? You see that? If you click the object that has your script, do you see that? How it's?
Oh yeah.
You see that, right? So we didn't have that before. So we just created that, and we did that by making it a public string. If this is a private string or nothing at all, it won't show up there. So watch, it'll disappear now. See?
Okay.
Not there. But since it's a public, it is now exposed to the whole program and to all the other game objects in Unity. So the advantages of this, so we'll see, I'll show you really quick. So now if you want to change that text, you can just type it right here in Unity. You could say like, haha, I changed it, Press enter, and now you press play, right? Now when I click, it says, haha, I changed it. And then you change it again, and then you click, haha, lol. See that? So now you don't have to actually go back into your code anymore. You could work from here,
cool,
for example, right? But just keep in mind that that's what public does. Public basically makes it public. It makes it exposed to the rest of the program, because usually things are contained within the script that they're in, unless you specify that it should also be visible to the outside world. And the reason computers do that is to save performance. Now it's not that much. Honestly, your whole program can be public now, and it won't feel it. But back in the day, it was very important to keep things like separated. But yeah, it's just kind of how it's done now. So now what we're gonna do is we're actually going to do something more, more 3D oriented, right? So remember this sphere here that you have knocking over these barrels, right? Everyone, we all remember this. So what I want you to do now is I want you to click that sphere, and I want you to find the animator component. You see it like right here, and you see the little check mark next to the component. Just uncheck it. So we don't want to use the animator currently for that sphere, because what we're going to do is we're actually going to animate the sphere in code on input. So this is a quick way to enable disable components, is just to uncheck the check mark. If you press play now, you'll see that the sphere will just be stationary because it's no longer being animated by the component animator. Right? All right.
Falls down.
And it has physics still. And if you don't want it to fall down, you would remove the rigid body component. But yeah, so now here's the interesting thing. So I don't know how your scenes are set up, but I'm sure you know the sphere is facing in a different direction for everyone. One quick way to check that, what the global orientation is right up here. You should see, if you turn your camera, you see how like my sphere's forward is in this X axis. You see that? Mm-hmm. How X is right here? Mm-hmm. Oops, that's terrible. X is right there, so that means that my towards my barrels is X. Now, what's it on your end? If you look, what does it say?
It's to the left.
So it's Z. Or what is it?
Oh, sorry, it is X. Yeah.
Is it? It's X as well.
Yeah.
Now, notice mine is in negative X because positive X is facing that way. You see, whichever way it shows, the X is like that's positive, and everything in the other direction is negative. So it's just like, you know, 7th, 8th grade math. I did this in my 4th grade in Serbia, but I know in America we did this again. So we're doing the plot charts, right? Everyone remember this? Remember this?
Yeah.
Right? Then you plot a point on this. Never thought this was going to be useful, did you? So you had, 1, 2, 3, 4. 1, 2, 3, 4. And then when you put a dot right here, that's like 1 and 1, right? And the dot here is 3 and 3, and you connect those, and then solve for the slope, right? It's the same shit, but this is how 3D is done. It's just, multiple points like this, and instead of 2 axes, there's 3. So there's a third dimension, which is Z. You know what I mean?
Yeah. So
these plot charts are basically the same as transform in Unity. So it's X, Y, and Z instead of just X and Y. If you're doing 2D stuff, it would be just X and Y.
right.
But yeah, so basically everything in this direction is positive, right? But what we don't draw, and we did sometimes in high school or in school, is this, right? So what's here? -1, -2, -3, -4, right?
Yeah.
And same here. Negative, 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 negative. So same applies in 3D. When you have these colors up here, so this is all in positive X, positive Z, positive Y. Now, for my instances, since this is positive X, towards the barrel, it's probably negative X for me. What is it for you? Is it positive X or negative X?
Towards the barrel?
Yeah.
It is positive.
Okay, keep that in mind. What about yours?
Mine's positive Z.
Positive Z. Good. So this is how you check, right? Just remember that. That's like your global orientation.
Wait, sorry. Which are you asking? Which arrow is pointing at the barrel?
Oh, no, I'm asking like just if you just check your scene, kind of like see how mine is. If you have an arrow pointing towards the barrel, that's probably in positive. If it's pointing away from it, then that means that you're actually going to be moving in negative of whatever that is.
Yeah.
Does that make sense?
Yeah.
So you said you're positive X, and you said you're positive Z, right? Mine is negative X. It just depends on your scene layout. But check it out. So now what we're going to do is we're going to close this script editor that we were making earlier, and we're going to go back to our project, and we're going to make another script. Right click, create C# script, and then just call this ball. Very simple. So before you click it, just rename it right away, because then it'll name it in the script editor.
Alright, sorry, wait.
So just create a new script. So just right click,
Okay.
create C# script, and then name it ball. And once you have that, double click that to open it. So now we're going to write just a very simple ball script. And you'll notice when you open it, it'll open another tab. So you'll have your old script over here. So now what I want to do is I just want to copy and paste this if input get mouse button down, right? Just copy that whole bracket into our ball script in the same place and update. Like that. And you'll see that my text will probably show up red. The reason why it shows up red,
We haven't defined the variable yet.
because we haven't defined my text in this script, and we won't, because we're not gonna actually do. We're actually gonna get rid of this whole debug log. We're not gonna do that. We're gonna do something else. So now what we want to do is, and you know what? Let's rename it from get mouse button down to just get mouse button, because we want to be able to hold this. Okay. So now I'm going to explain another concept, and this is very similar to transform. It's tied into it. It's something called vector 3. So you're going to type it like this. So capital vector 3, and then you're going to name that current position or something like that. Or you know what? Just name it my position. Just simpler. Just like that. Is equal to space, is equal to space, and then you write transform lowercase t dot, and it'll tell you all the different things that are in transform, position, and then semicolon. So transform dot position is a type of vector 3. So remember how we had bools, strings, ints, and float? So vector 3 is another one of those types, but it's a specific type that stores an x, y, and z value. It's basically stores 3 floats. So it stores 3 decimal numbers. Stores an x, y, and a z value. The reason why there's a specific structure for vector 3 is because it's just used so commonly in any kind of 3D transformations or stuff that you do. So what we're doing with this one line of code right here is we are storing our current position of the ball in the variable myPosition. Now what I'm going to do is I'm going to do so in the next line after the semicolon, so you do myPosition dot, now this depends on your side. For me it's .x. For you it's also .x. For you is .z,
Yeah.
right? So do that. Just type myPosition dot whatever the vector, whatever,
Whatever vector is facing the barrel.
yeah, whatever vector you want to work with, basically. In this instance, the one that's facing the barrels. Yes.
Okay. So wait,
So let me check for you and make sure. Yeah, you seem to be in negative z.
Yeah.
So see, that's z is that way.
Okay.
You're in, yeah, exactly. So you're using z as well. So you should write myPosition dot z. I'm writing myPosition dot x.
All right.
So myPosition dot z or whatever. Now there's 2 ways of writing this. I'm going to show you first this way because it just kind of makes sense, and I'll show you the short way. Is equal to myPosition dot x or dot z, whatever your thing is, plus 1 f. I'll explain why it's f. The reason why it's f is because it's a float, and you have to make sure it's basically it's a decimal, but without having to write, you know, this. It's just a C# thing. Whenever you're working with any kind of decimals, you have to, or when you're making a float, you just have to put that little f there. And we'll do that a few more times. So that's probably one of the few things that y'all will have to remember. And so yeah, just plus 1f, and then semicolon.
So if you wanted it to move faster, you could do like 2f or 3f.
Yep. But we'll get to that in a second.
Why
Now,
do you want it to be float? Why do you want it to be?
it has to be, because everything in vectors, x, y, and z, it's always like an increment. You're never moving like by, you know what I mean? Because the world values are kind of like when you move something in Unity, you see it goes from like 0.1, 0.2, yeah, and everything in between. It's actually the CPU in a computer has lots of floating point cores now that literally just calculate down to like the 100th. So it's like a precision thing, and you have to do that in 3D because things aren't just integers. A lot of numbers that you divide, you never end up with a whole number most of the time. So myPosition.x is equal to myPosition.x plus 1f. So now we have changed the variable myPosition's x value, and we've increased it by 1.
Yeah.
Now the last thing that we have to do is we have to assign that new variable that we just modified back to our transform position. So you create a new line and you just write transform dot position is equal to my position. So we created my position as a vector 3. That's why we had to write vector 3, and that's why it's in blue, because it's a type. Well, I'll explain what that means more elaborately in a second, but basically this is where we're first creating it. Just like over in Hello World when we created this public string, that's why we had to put string up here to tell it, okay, this is going to be a string, my text. And then later you don't have to. Later you just say my text. Same with my position. You don't have to keep saying this is a vector 3. As long as you said it the first time, then after that you just use my position just like that, just the name of it.
Okay.
So now what happens is
transform position is, sorry, can you talk through each line and what each one's doing?
So we'll basically we'll look over each one, right? So what happens here is we're declaring my position as a custom variable is equal to transform position. Now,
which is a function that Unity.
So yeah, so in Unity, whenever you write transform like this lowercase, you are accessing the transform of the object that the ball script is attached to.
Cool.
And then you do dot, and then you get the position of that transform.
Cool, okay.
Then what we did was we incremented that one vector. So my position dot x, this could be dot y or dot z.
Yep.
Those are the only things that are stored in a vector. And then we just took the same, we took itself basically and added 1 to that.
Cool.
So now it becomes itself plus 1. And then we assign it back to our transform position. So like here, it's still the movement hasn't happened. It's here that the movement actually happens. Okay. Because we now put it back to the transform position.
Gotcha. Okay.
Right? So now if you press play, you'll notice it will probably go extremely fast. Oh, wait. Forgot to add to our ball, right? So take this script and add it to your sphere. Let me know you have that.
Cool.
And now if you press play, it'll probably go way too fast. Like check up here. It will go like really fast. And probably in the wrong direction if we didn't do it right. So for me, it went like this, right? So watch. So it went in the wrong direction. The reason is because I'm adding 1, and mine is actually a negative x. So instead of adding 1, I should actually be subtracting 1. And if it went in the wrong direction for you and it went too fast, we'll fix the speed. But
I don't see anything happen.
Mine's not working.
you didn't put the script on your sphere.
Okay.
So let's scroll down there. Let's see it. Yes, you have 2. Just remove 1. Just right click it and yeah, and then remove component. Yeah, go back to this ball script. Let me see what's going on here. Just in the ball script.
Oh.
So we have should be all good. Let's just try it again. So just
Maybe it's my view or something.
press play, and then you have to click it in game view. Remember that.
Right.
So do that. Yeah, see, it goes.
You saw it?
Yeah, look at it. Where are you looking?
Oh,
That's
down there.
no. This is the sphere you got, right?
Yeah.
All right. Now it goes in the wrong direction. Same thing because you're a negative z. So you should be subtracting 1.
Got it.
So go back to your script and subtract 1. What about yours?
Mine's not working.
Okay. So now what we're gonna do is obviously if you want to decrease the speed of this, right? The first thought would be to just make this 0.01 instead of 1, for example, right? Make it slower. So just go ahead and do that.
Sorry.
So mine looks like this now. Let's check here. So mine looks like this, very kind of inching slowly as I'm holding, and then it'll eventually barely, doesn't even have enough force. See that? So are yours doing the same?
Well.
So you have to hold it in game. Remember?
Yeah.
Yep. Very slow, right?
Yeah.
Now, this is actually an incorrect way to do it. To just kind of like, it's too fast, so I'm going to make it 0.01. And I'm going to explain another concept right now, which is also a little bit computer science, but it's important to know. So, every computer, or pretty much most machines, have varying performance. Like my computer, your computer, all of these 3 computers have pretty varying performances. When you're incrementing something by a set number, like 1, for example, and because of the nature of programming, and this is just kind of running basically as fast as your computer can calculate it, this if statement. So on a faster computer, this actually moves faster than on a slower computer, which is actually incorrect. That should not be the case. We are developers that are going to be developing on God knows what hardware, so you don't really know when you're writing software. You have to account for many different kinds of hardware. Now this is what was interesting about console games and why console games were always better than PC games, like looking at least, for the performance, even though console games barely had any, even close to as much performance as like a PC, they ran them a lot more optimized. One of the reasons was because the PC ran Windows and all the other things on top of it. But another reason was because consoles, when you wrote a game for Nintendo, for example, every Nintendo in the world had the exact same specs. So when you incremented by 1, every Nintendo all around the world incremented by 1 at the exact same speed because the chips were made exactly the same. And this was actually great for console developers and stuff back then because they knew exactly what they were running on, and what they did in the lab was exactly what everyone got at home, basically. But since we're all cross-platform developers, we don't have that luxury, for example. So there are these little helper functions written that basically calculate the actual time in seconds, not the, just a rough number like 1.
Yeah.
So instead of just incrementing by like a decimal of 1, I'm still going to make it 1. But what I'm going to do right before the semicolon and the 1F, I'm going to do a times, so like a multiply right there, just a little star. And then I'm going to type this. I'm going to type time, like a capital T, dot delta time. Now what time delta time is, if we debug log this, each of our computers would have a different time delta time. That's basically, you know, the amount of milliseconds or whatever your CPU takes to run a cycle. So that's the normalizing factor in something like a movement that happens on update. Is basically, it doesn't, you know, just increment by 1. It increments by 1 times your CPU speed. So that's how we kind of keep it steady across all platforms. So just remember that when you know, time delta time, that's what it does. Is if anything's running constantly on update like that, and you're incrementing some numbers, you should increment it by the number times the time delta, because that's what basically keeps it consistent across all machines. So now you should probably see the same effect as like what a decimal point did earlier. It'll probably go at roughly the same speed, but now it's actually doing it correctly, because it's actually, you know, keeping in mind, like, you know, the speed of a computer. Just picture, like, if you will, like a really slow, laggy computer, just lagging, you know what I mean? Like every second is like another frame that renders, like just can't barely do it. So that computer still would, the ball would be in the same distance as like a super fast performing computer, because it's actually offsetted by that time delta. So if you're running Photoshop and you're exporting a video and you're rendering some 3D and you're doing all this stuff, and then you run your game, it'll, even though it's really choppy, it'll still move. That time delta will kind of like correct itself based on how fast your computer is currently calculating. So just keep that in mind. Again, you know, it's just a little bit of trivia about the CPUs and the Nintendo and all that, but I feel like saying those things helps it like sink in a little bit more.
Why is it so slow?
So it's so slow because the number is so low. So instead of making it 1, make it 10, for example. Now you can make it 10. It's like, it would be correct to do so.
What does delta time mean?
So I just explained. So basically, delta time is offsetting for the speed of your computer. So a mobile, like an iPhone 4 and an iPhone 6, iPhone 6 is way faster. Yeah. But, you know, iPhone 4 character shouldn't be slower than an iPhone 6 character. They should both be the same speed. And the time delta is, think of it like literally, if we just outputted the time delta as a debug log, we would all have a different number, because each of our computers calculates at different speeds. But it would be very slightly varying, practically nothing.
Well, what does the number mean? Like, what does 1 mean? Like 1F?
So 1F basically means like 1.000. It's basically when you put F, you're just basically saying that number, it's a float. It's not an integer. If you didn't put the F, because my position .x can never just be a whole number. It's always like.
Yeah. But it's the 1 means the speed of it moving, like adding up.
So you're in this case I'm subtracting 1. Yeah.
So basically, like if the plane, like there's no number, so like
So it's Unity has it's a global unit value. Yeah. So if you just kind of look, it's roughly like, you know, 1 unit in Unity is like 1 meter, kind of roughly. Okay. But yeah, you know, you can kind of see it for yourself. Like, see if I move this, like in Z right here, you can see how much the Z increments. See, so this is 0.4 Z, and this is 1.4 Z. So that's 1. That's a distance of 1. Okay. So in our case, we're moving. So when time delta happens, now pay attention here. So when time delta happens, see, that's a distance of 1. See, the difference is 1.48 and 0.48. So our code basically does that much distance in 1 second.
Because, like, this is really similar to like Arduino stuff. But Arduino works in like milliseconds.
Yeah, it's different because those are so slow. Like, they're really, and you have every little piece of performance counts.
So basically, here is like per second it moves like the 1 unit in the Unity.
Yep, because we wrote 1. If we wrote 10, then it would move in that 1 second. It would move a distance of 10, so it would be technically faster.
So, but when you did 1F, it's like faster. When you did delta 1F, it's like much much slower.
Yeah, so the reason, yeah, so let me explain that, right? So the reason why when you put time delta and it's much, much slower is because when we were literally incrementing by 1, that's this distance. Now check this, right? So how much distance was that? It was like this much, right?
Mm-hmm.
So you are actually incrementing by 1 every frame. Now, all of our computers right now, this simple scene, are rendering at over 100 frames per second. That means that in 1 second, you actually moved 100 units in Unity. Does that make sense? So when you put time delta, you're basically,
1 second.
yes.
Okay. So before the 1 is per frame.
Per frame,
This
exactly.
is 1 per second.
Yeah.
Okay.
Yep. So that's what the time delta does.
So let me ask you this.
Yeah.
Can we, so if I copied our if, the whole chunk there,
Yeah.
and then pasted it, pasted it and then changed it so that it's get mouse button 1, and then change my position .z plus 1f.
Then you can go backwards with the right click.
With the right, that would
Yeah.
work?
Yeah, it would work.
Can I try?
Yeah, you could try. That's good. That's exactly how it works. That's literally how coding works. It's that simple. When you're doing like a very simple input, you will basically do 4 ifs like that. One is for the left click, one is for the right click, one is for the forward, one is for the back, for example.
Okay.
That's how most people do it, yeah.
And then, so like if we were coding for the Vive, we would have different.
So yeah, they have different if statements there. It's like a different, yeah, so they have their own like thing, like for the trigger or for the touchpad.
And will that come up like as you know how we would suggest to get mouse button?
Yeah, it does. You just have to know what to start typing. Yeah, but it does. That's the beauty of C#, is that it's a very clean programming language, and everything is always exposed. So if it exists in Unity, and it's properly written and stuff, once you start typing, it'll basically tell you everything that's underneath it.
Cool. This
Yeah.
is giving me a compiler error.
So unexpected symbol end of file. So let's see what that means. So usually it tells you the line. So if you go back to the error, right? If you just double click the error, it'll actually pull up where the error happens. You see it's blinking. So I'll just click it.
Cool.
And it'll tell you there. So you have another extra curly bracket. So see, you opened it here, but you didn't close it there. So I think you put it.
Oh, gotcha.
You get it?
Yeah, so that one has to do with that
So you can just delete that curly bracket right there where I highlighted it,
Gotcha.
and then it'll fix itself.
Okay.
Actually, no, it won't. Sorry, I misled you. You have to you just put another one there.
You have to close that one.
Yeah, close that one, and then you're opening another one, and then
that one.
and
this
then
one closes that one.
and then that one closes the final class. Yeah, that's good.
Cool.
So now save it, and that should work.
Can you explain the vector 2, 3, 4?
Mm-hmm. So this is a vector 4.
Yeah.
Says that. Yeah, I've actually never used the vector 4. Vector 2 is just x and y.
Okay.
But it's exactly the same thing, except you just won't find a z in there. Vector 4, what is vector? I think it's like, Jesus.
So every time you want to address the
4-dimensional vectors, what's that? Time or something? But yeah, if you're ever moving anything in 3D, you're probably going to be using vector 3.
okay.
So yeah, so now I want to teach you another cool trick, right? So remember how we did our public string and then we, made it my text?
Yeah.
So let's do the same thing up here, but instead this time we'll make a public float.
So we'll do it above.
So out of any of the voids inside the class.
Got it.
So usually it's written kind of like up here.
Wait, one more.
Yeah, sure.
So if I want to just like click the right button and bring the ball back to where it was, can I address like
Just like
position 8 like X, Y, Z, and then I give them X, Y, Z.
yeah, so just like how he said, he literally just copied the function and he just instead of plussing it, he minused it,
Oh.
and on the right click.
Do you want to just reset? Like you don't want to drag it back. You want to just reset it.
Mm-hmm.
Or you want to set it back to where it started.
Yeah.
So you would have to store the starting position, and then on right click you just set it to that starting position. It's very easy to do, and we could do that. So but first, before we do that, I want to just show you this. So start typing up here a public float. So this is a float that will be accessible to the rest of the program, and we're going to call it my speed. All right, is equal to 1f, for example. Now, wherever you had the number where you're subtracting, instead of the number and you're timesing by time delta time, now just put my speed there. So it should be my speed times time delta time.
Cool.
Anyone got that?
Yep.
So now, if you go back to Unity, now when you click the sphere, right there it should have, in the component, it should have my speed. It should say 1. See that? So now when you're holding the click, so now it's moving really slow, now I can change my speed on the fly.
I'll see it.
Something like
I got
5.
it there. Why am I getting those there?
That's it.
I'm in the wrong place.
So you have, oh, you have the semicolon.
Oh, okay.
Sorry about that. Yeah, so whenever you end a statement, you have to put a semicolon.
Alright.
Yep, definitely.
Okay.
Yeah, so now you could change the speed over there. Just you can actually do it in play mode too. That's the beauty of it.
Oh, okay.
Yeah, you could change it to whatever you want. And if you want to go backwards, you can make it -10. It would basically do the same thing.
Oh, cool.
So just try it out. Oh, did you increase? Did you change it in the script? Go back to the script. So you have yeah, you still want F there. You only did it on the right click.
Oh yeah. Okay.
That's why it was going so slow.
Yeah.
So that's just one thing about doing the publics is, and now do you kind of get why it's F? Because see, it's a public float. So it just kind of has to be that. If you made an int, you know, like number of kids or something like that, that's like 3 or 2 or 1 or 0. You know what I mean? It don't need the F there. It won't work with the F. It's just a way for the program to just be sure that you're specifying things. And it might be a little bit different from like something like JavaScript, where anything can be anything, like any variable is anything, you know. And that actually slows things down because the compiler then kind of has to interpret what you actually meant. Whereas C#, it's a strongly typed language. That's what it's called. So you have to define exactly what you're doing. But yeah, that's just like the very simple of the you know, moving transforms and stuff. But yeah, let's do, so y'all probably had this thing for a right click to go backwards, right? So just for me it's plus here. Yeah, so then it'll go just like that. Now, just to show you a few more of these, let's say instead of using get mouse button down, watch here, so we do input get key down. Actually, just get key. And then just quote, and then like something like W.
Ah, awesome.
Something like that. Let me just make sure that works. Yeah. Okay. So let's do that. So just type, instead of get mouse button 0, just get key W. And then for the backwards, just do key S for backwards. And now I want you to kind of just look at your world and figure out what side to side is. In my case, side to side is Z, and yours will probably be X, since Z is forward. So copy both of those S and W's, the whole brackets. Oh, sorry, just change the mouse button to input.getKey.
Why is it W?
Oh, just because WASD. See, mine are even color coded here. It's just the first person shooter thing. Think of them like the arrow keys, like the WASD.
Yeah, but which one is the, like, wait, is it?
So it depends on your computer. So one's a forward is W.
Yeah.
Backwards is S.
So that means.
Yeah, so yeah, basically. So instead of left click, make it W. Instead of right click, make it S. We could also do arrows if you're more comfortable with that. So yeah, I have input get key W, get key S, and I'll do get key A, and get key D to get to WASD. And instead of X, I'm using Z in my side to side. And for you guys, it should be the opposite. And I'll come around and make sure it all works. But yeah, oops, ooh,
Unexpected.
went crazy. I'm gonna check you right now. Yeah, just check around for it. See, mine works like this. It's doing that. Let's see. So,
Oh yeah.
yeah, so you have to do it in you see the parentheses like that? So when you start typing get key, then you open parentheses, and then that's where the quotes go, in the parentheses, and you close it right there. Yep. And then you do the same thing with the other one too.
So, and then you do this 2 more times.
Yeah. Yeah, and then this one would be A, and that one would be D. And now instead of Z and Z, you're going to be X and X. And same thing down there.
I feel like I'm good, but it doesn't.
Check it right now. And if you want to do the W up here, you can do the same thing.
Sorry, no.
It actually updates the script
Oh.
even at runtime. Sometimes it doesn't work if you have a lot of things. Yeah, because you still have the left click for the forward, remember?
Oh, that's right. Okay, I'm with you.
Let's see. So just open it. Yes, you have. Yeah, you forgot to put another parentheses in there. You see how it kind of made it orange?
Yeah.
That means that thinks it's a string because you didn't close the quote after the
Oh,
D.
the quote. Got
Yeah,
it.
when you close the quote, see now it knows that that's actually parentheses and not just. But there's a few more things I see here. Yeah, same thing up there.
Yeah.
Before.
And then, does that mean I'm missing a?
Go up one more, I think.
Oh.
Just save. Let's just. Yeah. Fix
Equals symbol in the file.
So let's see, go back. So you might have had at the end. Yeah, so I think it's expecting another curly bracket at the end that you might have deleted.
Yeah. Needs one more.
Yeah. So that one closes the function, that one closes the class.
Okay.
One quick way to check where your curly brackets end and begin is if you just kind of click them. Notice, look, if I just kind of click the beginning, see how it shows me where it opens and where it closes. See the little highlight?
Oh, yeah, yeah.
So it's just a quick way for you to see where they start, where they begin.
Make sure each one's closed.
Yeah, and you can know which one opens where and which one closes where.
And does it do anything if you don't have a closed bracket?
You have to always close them.
No, I mean, like if you didn't have one here, would it show?
Oh, it wouldn't. It wouldn't. It would just not show.
Wouldn't show. Okay.
Yeah, and that means like there's one missing. So I got that with you. Good, right?
Yeah.
So very, very simple.
My side to side is not really working.
It should be just you're probably like kind of in a weird angle, so you don't really. Oh, you're not. Let me see.
Oh, okay.
Maybe you're just not seeing it.
See, it's this one here. Just do that.
Oh, here's the reason.
Oh, I have
Because,
this.
yep,
Yeah,
yep,
yeah.
you got it.
Cool.
Yep.
Was this supposed to be Z?
Yeah.
It's supposed to be X. Oh,
Oh, wait.
for side to side, it's supposed to be X.
Yeah, yeah. So both of them should be X there. You're right. All right.
Yeah, great. Cool.
All right. Let's take a quickie break.
Yeah. Cool.
It's not hard, right?
No,
You just some of the syntax you have to remember, but once you get it and you find places where to copy and paste them and stuff,
Mm-hmm.
it's not very hard.
Yeah, and once I understood,
One direction, all the other ones were kind of logical, right?
yeah.
Yeah, we're just taking like a little 5-minute break. They're all pretty much like the same. You got viewer on tab.
Wait, so after the play,
Yeah.
I copy and pasted a bunch, and then you're not moving.
Let me see.
So this is it, yeah. And then, what if I copy and paste it?
This sphere? You should be right.
And then it doesn't follow this anymore.
Click in game. Click your mouse back into the game. Yeah, they all move.
Oh.
Yeah, that's the only reason. Yeah, it's if it has the script, the
Oh.
behavior applies. Yep.
Oh, awesome.
Right? You can put that on the walls, you can put it on the barrels, you can put it even on the character now.
Oh, nice.
So you can actually move the character as he's dancing. You try that.
How?
Just put the script on the character.
Like,
Well, maybe not like that. I'm not sure where it will land. But just find the character up there in the hierarchy,
Oh, yeah.
and then just put it on there. Yeah. Yeah, and then try it. You have to click in game. Yeah. See?
Oh, nice.
So that's the great thing about scripts. See, they're components.
Okay.
So you can have multiple components on an object, and you can then reuse that script in many different places. And that's one of the hallmarks of how I teach is like at the end of this, you'll all kind of have a bunch of these little helpful scripts that you can always kind of go back to and reference.
Nice. Thank you. How do you put it onto the arrow thing?
Whatever.
Instead of the WS.
Let me see. So I think for arrows, input get key. Since it's not like a typable value, you should do key code dot left arrow, something like this. I think should look something like that. So key code is also another way to do it. So you can do key code dot w. It's the same thing. I just kind of showed you a short way of doing it with the quotes. You could do that when it's like a letter. You could put just the name of the letter in quotes. But if you wanted to do like that, you would do in the parentheses key code like that with the caps. Dot, and then it'll show you all the different key codes. You should just start typing left, and it'll see a left arrow in there. And you can do the same thing for up arrow, right arrow, down arrow. If you just want to fix up the WASD stuff. That's a very like FPS thing of me to do. And
FPS?
first person shooter. Or frame rate per second. It was crazy. It would have taken me literally an hour and a half or 2 hours to render that video from yesterday. So I just threw it on YouTube from here, from the WeWork connection, and it uploaded in like 5-10 minutes.
Wow.
And then I let them do all the rendering, like online. Like it was just because it was like 4 gigs of recording or something, you know. So I'm just gonna keep doing that, and then you guys can always reference back to it.
That's awesome.
So yeah, I was just showing you earlier, you could technically now take that script and put it on the character that's dancing to move him.
What was that?
You could take that script that we just made and you could put it on the character, and now you can move the character.
That's pretty cool.
But see, now that you have the script on multiple objects, I can make the character move faster than the ball by just changing the value on the character. See that?
Oh yeah.
So that's the great thing about exposing these variables to public, is that then you can modify the values for depending on the object that you use. And the only reason the barrels are moving is because of the sword. Because I have a collider on the sword. Yeah. All right.
So we put it in water last time. Does the water have physical influence over the objects?
No.
I can't really tell. But
Doesn't.
is there a way to make it do that?
Yeah, there is. There's multiple ways of doing it. It just depends on the effect that you're going for. I also know there's a really good water asset that in the Unity asset store. These guys made a pirate game in Unity, and it's pretty popular. I play it too. It's really fun. And they had to design this whole water engine for all the boats to have accurate flow and stuff. It's not easy to get the right effect, but there's always cheap ways of doing it. You know, you could just put a plane under the objects and then just move the plane in code like that, and then you can kind of give that flotation effect.
Yeah.
And you can just hide it, you know, but the collider will still be there. So there's like I said, there's ways of faking it.
Okay.
But the wave itself is just graphical. It doesn't actually have a collider on it.
Cool. All right.
So let's see here. So before we get into the music stuff, I want to just show you just some simple little scripts and where to find them, right? So if you don't have internet for whatever reason, you can always find the scripting reference here in help. Just click help and scripting reference. Oh, it's actually pulling it up online because I didn't install it locally. In any case, this is where the whole code base lies. So say you wanted to search right here, you know, like transform move or something like that. You just search it. It'll show you a few results right here. The second one says transform translate, for example. Now, I'm going to show you this little script. So before we get into the other stuff, the reason why I showed you like this is not actually the best way to do this. This is the most explicit way to do this. So I literally showed you how we copied the value, changed the value, then assigned the value back. A much simpler way of doing this code snippet. So if you just look right here where, you know, in your forward, you don't have to do it for the other ones. Instead of typing all of this, and I'm just going to comment this out like that. So I want you to do the same. So comment out one of them, just forward or something. And the way you comment is you do like that /, star, then you go down to where you want to end the comment, then you do a star and a /. So everything in between those should be grayed out. I got that? Okay. So the easier way to do this, a one-line way of doing it, is like this. You just do transform dot translate. And you see it auto-correcting you there. See that? And then you open parentheses, and then it's expecting a vector3 translation. So like the direction, basically, that you want to translate in. In this instance, I'm doing what? I'm in X. So here you do this, right? And you have to type it like this. New vector3, open parentheses, and then here I'm calculating. I have X, Y, and Z. So X, Y, and Z means the first one is X. So just remember that. It's always X, Y, and Z, right? So when you're doing the commas, it's always the first one is X, comma, Y, comma, Z. So new vector3, and then in here is my speed. For you, it'll probably be in Z for the forward, I believe. Yeah. And then everything else is just 0 and 0. You see how it says float? It wants to float X, it wants to float Y, and it wants to float Z. So I'm just, the first one for me is my speed. For you guys, it'll probably be 0, 0, and then my speed.
So not my speed.
And if you
plus
want
one?
to be like
No.
minus, then it's negative plus 1.
Say that again?
If you want it to be -8.
Yes, exactly. So yeah, it's not +1 because when you're doing translate, that's a function on transform that's basically plussing it or minusing it, depending on what you have there.
Gotcha.
Right? So you're translating it by a vector. So the reason why you put new, and in some places you do and in some places you don't, I'll just explain it really briefly. Because if you just put without the new, it'll probably tell you an error, something like cannot be assigned, something like that. What that means is like when you put new, you're basically creating the variable right then and there. You're not giving it a name or anything because you're just using it in that one moment and then you don't really need it. Another way of doing it is, yeah, you could do vector3 my vector is equal to and then new vector this and that, then you can just say my vector. But in this instance, we just really are using it here temporarily like this. So for me, it's actually my speed. It's negative my speed right here. And then you can time delta time in the individual comma, or you could literally, with vectors, you can time delta time the whole vector. So you can do time delta time on top of, outside of that parentheses. So in programming, all the order of operations kind of stays just like how we learned in school. It's like multiplication first, then addition, subtraction, all that good stuff. Everything in the parentheses gets solved first, and but yeah, you're putting it literally like right outside there, and then that will time delta the whole vector, not just the individual value. And then semicolon here, and then we'll do the same thing. So that's a one-line way of doing it. And it works. Right? Does it work?
Mine just kind of shut off by itself.
Did you time delta? Go back. Let me see. Maybe you forgot to if statement it. Let me see. Oh yeah, because you're doing it on update, you're translating. So it's literally it's just the moment the program starts, it goes, you know? So you have to do the if statement for whatever you want it to happen on.
So I should comment out this part.
You can just copy and paste that and yeah. So like that.
Yeah, right?
Yeah, with the bracket, because you're gonna need the bracket. Yeah. And then just close the bracket right after it. Yep, and then save, and short. So yeah, that's a one-line way of doing transform, translate. Now, here's another thing, right? So let's say you Googled, let's say you just got amnesia after this class. You just don't remember shit. Like, I don't know anything, right? What the hell are you talking about? If you just Google like this.
I don't know what I did, but it's flying.
Wait, let me see.
It's like spiraling.
Did you?
See what it's doing?
Yeah, let's go back again. Let me see. Oh, because get key. Wait. You sure? Just go back again. Just unplay and press play again. Just let me just see it. What happened? Probably like bounced off of something. Press play again. Well, don't hold it yet. Just don't hold it in the beginning. Just press play and just start it again. Don't touch anything. Okay, press. Yeah, it's just because it bounced off of something. That's why. Because it was going really fast. So it lost its once it hit a barrel, it kind of bounced off it.
Wait, no, it's moving like left and right too. See what it's doing?
Oh, yeah. So that's the reason why it's doing that is because transform translate is translating in the local orientation of the object. So once you hit like a barrel, then it starts rotating, then its forward facing changes.
All the axes change.
Yeah. So one way of fixing that is when you do a comma right here, You see how it says translation, and then it has a space relative to. So you could do space dot world or dot self. So in this instance, maybe you want dot world.
Okay.
That's just, again, it's a one-line way of doing it. It's just a matter of preference. This is definitely the more explicit way of writing it. This is like the more coder, like one-liner way of writing it. So yeah, again, let's say you just got amnesia and you forgot all this shit. You just Google, like, how do I move transform Unity? You just Google it like that. And then what does it show up first? Transform translate. See that?
Yeah.
Right there. You click that, look what it gives you. There it is. It just gives you a little code snippet. You can cut out and
It has a space double.
yep.
Nice.
So it has a few different ways. In this instance, it's using vector 3 dot forward, which is just a simple way of saying z. 0, 0, 1. But it's just vector 3 dot forward, vector 3 dot up. It's just like an easier way of, instead of having to write the 0, 0, 1, whatever.
Okay.
So get used to that. Like if you just have a problem or you want to answer a question or something like that, just Google it. How do I move? You don't even have to say a transform. How do I move an object? Unity, and it'll give you the same result right there, right? It's very, very well made. Then what would be another good one to look up, for example? Yeah, like the inputs that we're doing. How do I detect mouse click Unity? Right, just something very plain English. Googled like that, shows up. Get mouse button down. See that? First result. You click it. Gives you some examples right there that you can just copy and paste and it works right away. So, like I said, if you just seriously just forgot about all this, YouTube disappeared, everything's gone, you cannot remember this class, but for some reason Unity's still up, you can Google it in very plain English like that, and you will find some pretty helpful results. Most of the time, you'll find the most common things are in the script reference. If you can't find it, or if you want more, this is another great place. So the answers part, they always have people that ask a question, and then there's always a best answer. Someone already replied to the specific answer. So a lot of times all the questions have already been asked, and you just look it up and you'll find someone already answered it, and you can copy it. If you're brave and you really have something that you have no idea how to do, you can even ask the question and someone will literally give you the code snippet that works. So yeah, it works pretty good, and it's a very, very helpful community. You will find like pretty much everything. Like in your instance, for example, you were interested in webcam, right? How do I pull webcam textures? You just Google it, right? How do I get webcam? Or how do I get camera texture Unity? Just type that. It says, camera. See, it's assuming I'm talking about the camera in game. So say webcam. Just kind of adjust your query a little bit, and then there it is, the webcam texture script, and then it has a bunch of things here. This is because it's actually showing you the whole top level of the webcam texture and all its different properties, like the FPS, is it playing or not, that's a true or false, some functions like play, stop, pause. But the second result is going to give you the actual code. See that? So don't be discouraged if the first result doesn't. So yeah, how do I get webcam texture at Unity? The second one will literally give you the script right there. Then you can take this script, just copy and paste it, apply it to an object, and it'll do the same thing that I did in class yesterday, where it just put the webcam texture on a plane. So yeah, this is really good to know, and just know that you could look up a lot of this stuff, and as long as you know how to look it up, you can learn a lot like that, even on your own, the specific things that you want to learn. My goal is to just teach you like really the concepts, and just as much trial and error and like doing it, and then once you get comfortable with it and like I can do this, then you know where to take it next from that. So yeah, then the other thing that I want to show you, and y'all are gonna find this interesting, right? So now this is all fine and dandy, moving objects and stuff, But how do objects talk to other objects? And what if like one object wants to influence another? What if one object wants to create another object? Like say, we learn how to do this, right? We learn how to make a prefab and then drag the prefab into the world. That's easy, right? But if you have a launched app or a game, you're not going to be there to drag things out into the world. The program needs to be able to create an object of its own accord based on some condition, right? So let's do these barrels, for example. Let's create a barrel on top of this sphere every time we click a certain button, for example, right? So let's try that. So take one of these barrels, whichever one you like, and save it as a prefab. Like I got this one. It's already got the physics and everything on it. So you drag it from the hierarchy into your project like that, and then it just kind of saves it. And you'll notice that it turns blue. So the blue means that it's linked to something in the project. Excuse me.
And sorry, to make it prefab, you just drag it down, right?
You just drag it down to the project, yeah. All right. So back to our ball script, right? So now up here, right under my speed, where we wrote, right? Now we're going to create, and we're going to explore a new type of type is public game object, like this, capital G, capital O, barrel prefab, something like that. And then just semicolon. Doesn't have to equal to anything.
Okay.
Now, if you go back to the ball, just go back into the Unity scene, and you scroll down to the component, you should see it should say right under my speed. It should say barrel prefab, and then it say none game object right there. You see that? So it should look like this. Right under it, it should say that. So go back to here and save the script. Make sure it's like this. Public game object, barrel prefab in your ball. Semicolon.
Okay.
Works?
And you drag the barrel to the game mode.
Yeah, it has to be capital O. Yep. And save it. You got it? Okay. Yeah, and then, like I said, you take it. Yep. So now take that barrel prefab and pull it in there. Now you've just linked something from the project to your script, to the object that we're working with right now.
Yeah.
So now let's have fun with this, right? So the first thing that we need to do, and just to make the distinction, because I think you already kind of get what a prefab is. A prefab is basically just the template. It's like the object's properties and all that. It doesn't yet exist in the world. We have to make it exist. And the way you do that is through a function called instantiate, which basically makes an instance of that object. And I'll show you how to write that right now. So we're going to do it on mouse click, for example. So right here on update, just above all the movement stuff, we'll do an if input get mouse button down 0, just like that, just like how we did before. Just make sure it's mouse button down, because we don't want to just make barrels as long as we're holding every frame. That will be insane. But you can see that for fun later, what it looks like. Because that down is literally just on the moment that your finger pressed it down, it only fired once. So yeah, just do that, leave some space in there, and now what we're going to do is we're going to start typing like this. Instantiate. So just write insta, and it will kind of autocorrect you right there. Instantiate, and then open parentheses, and then it's expecting an object original. So it's expecting the original object, so the prefab. And in there, you type barrel prefab, which is the thing that we just linked, right? So instantiate a barrel prefab, and then comma, and once it says transform parent, just ignore that. I don't know why they made it like that. It actually just wants the position. So the first thing is the object that we're instantiating. Then the second thing is where are we instantiating? We want to instantiate it right on top of our sphere right now. So we're going to do transform dot position. And that's always whatever the script is attached to, which is the ball script. So that means the transform position of the ball. So we're instantiating a barrel prefab at the transform position of our ball, then do another comma, and it's going to expect a rotation. So we're just going to do barrel prefab dot rotation. Wait, barrel prefab dot transform dot rotation. Sorry about that. Because it needs to also know what orientation you want to spawn the barrel in. And we're just going to spawn it in the same orientation that we saved it as, right? Make sense? So it should just look like this. And then close this, and then a semicolon. Now, I hope it'll just work like this. If it doesn't, there's a few other things I have to do, but I just want to do it as simple as I can and just see if this will actually work.
Oh yeah.
Right? So now press play and just start. Oh, what's going on? Oh, it doesn't work for me. Works for you? Wait a minute. Oh, I think because I didn't link my barrel prefab. There. So how's that? Yeah. So if you didn't have mouse button down, if you had just mouse button, then you could literally hold and it will make way too many. So let's try to click it. See?
Nice.
Cool, right?
Yeah.
So now you can do that kind of stuff at very specific places, like making sure that transform position is something else. So say you wanted, you probably wouldn't do it like this, but say you just really wanted like a certain place in this world, just anywhere.
You
Say,
make it rain?
You can. So let's try that, right? So here's how you would do that. So we're gonna create, now think of rain, right? Rain kind of starts above and it's kind of random, right? So the way that we would do this is we have to create that random position first of all. So inside this if input get mouse button down, I want you to start typing like this. So vector 3, and then just call that my random position, something like that. So vector 3, my random position, is equal to new vector 3. And now here's where some of the magic happens. So y is up. So the y is the only one that's probably not going to be random. So just for starters right now, let's just make them 0, 0, 0 like this, and then we'll edit each one. Okay. So this middle one, let's make it something like 50. So up in the air, 50, right? For the x and the z, we're gonna have to type this in this instead of the 0. You're gonna write random like this with the capital R dot range capital R, and then it's gonna expect a range. So just let's say negative 10f comma 10f. So anything between those. And make sure you got that parentheses. So just like this.
Because our plane is 5 by 5. Is that how you put the numbers?
I just kind of put 10. If it's
Okay.
5 by 5, we can make it bigger, yeah.
Okay.
The last one's 0?
And no, the last one will also, you just copy and paste this random range, the same random range function. If you want to, have this kind of very customizable in the editor, let's do this, right? So right up here where it says public float my speed, let's make another one, call it public float my range or something like that, equals to, I don't know, like 5f or something like that. So now instead of having random range minus 10f, you should have random range minus my range. So one is minus my range, one is just my range. So that's in between whatever you have up there. Everyone got that? Now the last thing is in this instantiate, instead of where it says transform position for the location, you should put my random position. Like that. So instead of where you have transform position, which is the ball's position, we're going to put my random position there. So every time you click mouse button down, it will calculate a random position. 50 float in the sky and a random based on your range, and then it should just fall like that.
I want to just be continuous. I just do get the mouse button.
Yeah, or you could just put no if statement and just, but that would be also way too many. There's a way to time it as well, if you want it to be on an interval. Okay, so does it work? There they come. Some might be falling through the ground because I believe like they're just going way too fast and the physics isn't set on accurate mode.
Why did it come like not like continuous?
It's because it's on click.
Even when I'm doing just mouse button.
It's still doing them one by one, technically. If you want them to all come at once,
Yeah.
there's multiple ways of doing that, but you could do it like this. You could do you could literally copy this multiple times.
Mm-hmm.
That's one way of doing it. So that gives you 5. This is not a very efficient way of doing it. So I could teach you this quick function, and this is also you'll see this in programming a lot. You'll type it like this: for a specific type of coding thing. So for open parentheses, integer int I is equal to 0, semicolon. I is smaller than, I don't know, 10, for example. So that's 10 times. Semicolon I plus plus, close parentheses. So I know this looks kind of weird, but I'll explain why it's like this. You know what? Instead of I, just make that x, just so it makes more sense. Int x is equal to 0, x is smaller than 10, x plus plus. Open curly bracket, and then close the curly bracket around your statement. So it should look like this. So what this basically does is it declares x as starting at 0. So for runs this, it's a loop, so it's called a for loop. So basically it will run this function as long as this is true. So as long as x is smaller than 10, it will run it, and then every time it runs it, x plus plus, that basically means incremented by 1. You ever heard of C++? So the reason it was named C++ was because it had some extra things on top of just regular C. In regular C, you had to write x is equal to x plus 1. With C++, they were like, why can't you just write x plus plus? And that makes it x plus 1. So when you see that plus plus, that just means it's incremented by 1. Instead of having to write the whole thing out, x is equal to x plus 1. So what this basically means is for loop, it's starting at 0, It's supposed to be smaller than 10, and every time it finishes, increments by 1. So first it's 0, then it's 1, then it's 2, and then it runs 9 times, and then when it's not true anymore, it's done. So this will basically, every time you click, it'll do that same function 10 times at the same time in one click. So now if we press play, it should do 10 at a time.
So I'm still getting an error on my before I
Yep, let me see.
saying it's in an instantiate. But I think mine was just a glitch.
So my random position isn't typed the same. Oh, you forgot to semicolon over here.
Oh, okay.
Yep. That's it. Just say.
The sign that have a smaller sign is not one.
Oh, I don't think you played it. What did it say?
I'm expecting some more.
Oh, you got it. Instead of comma, it has to be a semicolon on the for loop. That's just how it is. Yeah.
Okay.
Yep. Save that and try it again.
What about this?
It is similar. It'll say it back in. It just says that because once you broke it here, then it doesn't know what to do with the rest of it. I think. So now if you press, it should come 10 at once, right? Or however many you put. Cool, right? So they follow? Yeah.
Yeah. Cool.
Do you want to type out the loop so you can do more of it? Yeah, I wasn't really going to teach you guys the loop because it might be a little confusing, but that's just the simplest way to do a loop. And that basically, instead of having to copy and paste that same thing 10 times, now you can just edit that number there and it'll do it for you. So yeah, anything inside a for loop or a while loop, it keeps looping until a condition is met, which in this instance is smaller than a certain number. Then you can take that number and you can make that a public integer. Say like on level 1 there's like 10 barrels that fall at you, but at level 10 there's 100 barrels that fall at you. You know what I mean? So you can change that in your script, for example. Yeah, so it's just integer x is equal to 0, and then it's a semicolon between each of these.
Semicolon between.
So after x equals 0, then a semicolon.
Oh.
Then x is smaller than 10, then a semicolon. Because these are technically statements. I honestly don't know why they do it like that, but that's just how it is for this one. Hey, make sure you close the bracket outside of this here.
Outside of which?
Open a bracket here and then close it here, and just that's what I'm saying.
I just switched the barrel with another prefab, but it's not fun.
Hmm?
It's supposed to work. If I like switch the barrel
In the ball script.
in the over here. Barrel prefab.
So what are you using, sphere?
Yeah.
We'll try it. Let me see. Maybe chill. Oh, it's coming. I see them. They got made. It's just the sphere doesn't have a physics. Look up. Look up with your mouse. Just look up. No, just up. Yeah, see? They're just not falling.
Oh, wait. So I need to add this.
You need to add a rigid body to it. And then now when you create more, it would do it.
Oh.
You get it?
Amazing.
Right? Yeah, so one quick way to know if it's actually instantiating, just check in the left in the hierarchy there. You see how many objects you have? Yeah, it really is a lot of fun. So that's one way to reference another game object from one game object. So now the sphere is creating barrels, and the barrels can create spheres, and sphere can create dancing characters, anything you want. It's all prefab. So if the dancing character becomes a prefab, like this good sir right here, put a rigid body on him, make him a prefab. I'll get rid of the rigid body from here. And then in my sphere, if I, instead of the barrel prefab, I put the characters as a prefab and I click, and then I'll have a bunch of these characters fall. Because they didn't have a collider.
Oh, okay.
So I can do that. I can make a sphere collider. And then here we go. Click, and then there they are. And then they'll fall and they'll roll over and still keep dancing. Look at that, see? Here they come. Woo, yeah, party time. Look at that shit. It's so laggy. Oh yeah.
Like.
That's right.
Oh, sometimes I see the anime, or like animators on Instagram. They'll like do like a human body that like.
Dropping down, yeah, it looks funny.
They do what?
Like how do you, that's not rigid body.
Oh, to make it
Just
ragdoll physics.
Yeah.
I can show you ragdoll physics. We're gonna do that for next week actually, when we do more of more advanced interactions, the goalie stuff and stuff. That's where I do the rigid body. When the goalie kind of just gets hit with the soccer ball, he just like becomes like all physics and stuff. But yeah, for today, what I wanted to cover is one more important concept in programming, and then you should pretty much kind of have the baseline to do what you need to do. So the last concept I want to teach you today, and then we'll get into the music stuff and getting you ready to make a music video, is a manager object. So there's special types of objects in programming, and whenever you're making games or anything, and pretty much in the whole world, there's always some sort of management structure. So right now it kind of seems fine that we're spawning barrels from our sphere and stuff, but what if you had like 100 different objects that have to be spawned at different times, and there's different categories of objects, and maybe the character has a health spawn and a mana bar, and maybe like, in any case, like if you had a lot of objects, a lot of things going on in your scene, you should have something called a manager object. It just kind of manages all the object references, manages things like how much health you have left, manages what scene you're currently in, and etc. But the basic concept is that there should be an object outside of your moving objects that's always just kind of watching and just keeping track of what's happening. So trying to think of what would be a good example to use here for a manager object. Let's say well, actually, I think it'll make more sense when I do the music script. So let's just jump right into that, actually. So, oh, you know what? Before we do the music script, I wanted to squeeze one more thing in, and this actually is not related to coding, but it's pretty fun. So, and it was one of the questions that you had yesterday. So let's create a particle system, right? I'm trying to find the right time to squeeze this in. I think now's the time. So a particle system is a way to do like very simple effects. So let's say we want our sphere to be like fiery or something like that. So here's what we're gonna do, right? So we're gonna go on Google, and we're gonna Google fire PNG, which makes it, whenever you Google something PNG, it'll try to give you like a transparent version of it. So just Google something like, or I banged it apparently, fire.png, and you want to find one that doesn't have like a obvious bottom, something like something like this. Something that's just kind of like more kind of circular type of thing. And just save it to your desktop somewhere. And then when you have it, import it into Unity. Okay. Let me know when everyone's got their favorite fire texture. That's another great thing about this is I love telling people to go on Google, find your own texture, because then everyone's project looks different, because people have different preferences. Yeah.
Bring it in the project, you said?
Yeah, just copy the texture in. Yeah, everyone got that? All right. So let's create a particle system. So the way that you create a particle system in the world is you go to game object up here, and then it should just say particle system right there. So just create that. And what you just see is these kind of white dots just kind of flying up. So we're going to tweak this now, right? So the first thing I want to do is I want to replace these white dots with our fire texture. So the way we do that is we need to create a material first for this. So create a material in the project, same thing, right click, create material. And we're going to call this material fire. Everyone got that?
Yeah.
Alright.
Where?
Oh, just make a new material.
Where?
Just in the project. Right click, create material. You should see this white sphere, so just an empty material. Now, I'm going to introduce you to something that you haven't done yet. Up here in the drop down, it says shader. So you can actually choose the different shader for your material. So we're going to use a special one for this one, which is a particle shader. You should see, like in that drop down, it should say particles. I want you to select additive. Okay? And it should turn into like this kind of square, like that. Everyone got that? So the new material that you created, up here, it should say shader. And you want to look for particles additive. Or additive soft, they both fine. And then take your fire texture and pull it into the texture slot there.
Is it texture slot?
Just, you see it's in the material?
Or was it not? Yeah.
Yeah.
Cool.
Got it?
Yeah.
Alright, so now we created our fire material. So you kind of get the difference between a material and a texture, right? The texture is just the picture, just the data. The material is actually like the property, like of the material, what it looks like, its color, its, you know, is it transparent, is it not transparent, is it whatever, you know?
Okay.
The material defines like the actual material. Is it reflective? Is it, you get what I mean? The texture is just like a picture. It's literally just the JPEG.
Okay.
The material is what you actually use in Unity. The material can contain multiple textures,
Okay.
right? So does everyone have this? You got your fire material? Okay. So now we're gonna click that particle system that we created earlier in our hierarchy, and you're gonna see it start animating again when you click it. And then over here on the right, you'll see like a shit ton of things. I just want you to scroll all the way to the bottom to renderer. You see that? Open it just by clicking it. And then in there, you'll see where it says material. You see where it just says this. You just click it, like not the check mark, but just the gray tab.
Yeah.
And it'll open it, and then you see where it says material. It says default particle.
Yeah.
So this is when you click your particle system, and you just scroll down to the bottom. So replace that default particle material with the fire material we just created, and you should get that.
Oh. So when I did that.
Did you make a particle system yet?
Yes, I did.
So-
And where do you-
So all the way at the bottom, scroll, yeah, all the way down. Render, you open it. Not the check mark, yeah, like that, and then you pull that material you just created into there, into where it says default particle.
So when I do that,
Oh, your material first. You have to. Oh, why didn't it update? That's weird. It's fine. I don't know why. It just didn't update in the editor, but it's good. So yeah, just scroll it all the way down. You have to like yeah, and you put it there. See where it says material? Yeah. So you want to put that in there. There you go. You got that?
yeah.
All right. So now let's tweak like kind of like the how much this comes out. And I don't want to spend too much on this part. We're just going to keep this very simple. So scroll up on your particle system. And I want you to change the start size. Here it should say 1. Make it to like something like 3. Okay. I think like it should be particles. You know, change the material from particles additive to particles additive. You know, it depends on the effect you want to go for. See, one is like soft, and one is like kind of like this. Like if you want it to be really brutal, you can do this alpha blended particle shader. So see, this it's really kind of depends on the effect that you want to go for. But you will find all these things here. I'm gonna actually go for alpha blended for this instance. Or soft. You know what? I can't make it. I can't decide. Doesn't matter. But yeah, I mean, go back to your particle system. So everyone got the start size to something like 3, so it's like really big like that right now, right? It's kind of animating up. Yeah, so click your particle system.
Okay.
Yeah. So the other thing that we want to do is we want to change the start speed to something smaller, like 1. Okay. Then notice how like if you just kind of zoom out, you see how like the beginning it just kind of pops in, and at the end it just kind of pops out. It's not a very convincing effect, right? So I want you to scroll right over here around the top middle in these. It says color over lifetime. Do you see that? I want you to check that right there. Open that, and you'll see a little white bar right there on where it says color. So I want you to click that white bar, and you should get this.
Yep.
Everyone got that? So now check it. So here this is like Photoshop. So we're gonna tweak. So up here, I want you to click. Oh wait, no, this is color. This is the alpha. Yeah. So click the top part of the bar right here to make one new thing, and then click right here to make another new control point. So make one here and click one here. Now select this first control point and make the alpha 0. And then select the last control point and make the alpha 0. And now our particle system fades in and out. So it fades in at the beginning and it fades out at the end, right?
Yeah, much better.
Right?
Yeah.
And you can tweak the amount, obviously, how much you want the fade to happen and stuff. Now at the bottom, you can tweak the color, for example. So like if I wanted to start like, black, or if I wanted to start like really orange or something and end up like really black, like gray, like smoke or something, you could do that. So it could look something like this. But you don't have to. Honestly, it just kind of looks.
The color.
So it's the bottom control points. So see, there's on the top, those are the alphas. On the bottom, those are the colors.
Oh, okay.
See how this lets you do alpha, this lets you do color. But in this instance, I don't think you have to change the color, just as long as you do that transparency thing. So that's pretty much the secret to getting like a nice particle system. The other thing is the shape. You see where it says shape? Right under emission. It just in the particle system.
Yeah.
It says cone. You can make that like a sphere, for example. And then I would make the start speed even less, like like 0.2 or something. I don't know. That's up to you. Just kind of tweak them. So this one's, it's a very big particle system. I would probably, you know, change the start size to like 1, change the start speed to like 0.05. And then change the radius of this like starting point to be like smaller. Something like that. But, you know, this is all just kind of tweaking. And there's all these settings here. I highly recommend, you know, when you just have spare time, so just play with it. It's pretty fun. So you take this particle system now, and you can actually pull it inside your sphere. Just kind of like that. Just like putting it literally in.
With a child.
Yeah, first you move it to where it actually kind of should sit, and then you child it to it, yeah. And now when you're animating around and stuff, you're actually, it has the particle system with it. If it does rotations and stuff, see that? So that's what mine looks like. Right. Now the last thing to make this thing kind of glow, is to make a light. Now just let me know when you're done parenting that particle system. That's very huge. Yeah, maybe make the radius of that sphere, you see, kind of pull it by the little, you see the little like control point of the edge?
This one?
Make it smaller, which pull it in, yeah. And then, move it up. I think it's because it's under the water.
Oh.
Yeah. So you think you have it in the sphere, but you don't.
Yeah.
Because you're not looking at it from the right angle. So you should probably, like, you know, rotate your view around a little bit until you actually see where you are. A quick way of doing it is you just want to put it right in there. Click the particle system.
Yep.
And just make, since it's already parented to the sphere, make it position 0, 0, 0. So it'll zero it out right on it. And then take this sphere.
Oh, I see it. Yeah, down there.
It might be the wrong sphere.
Yeah, you're right. Which one is this?
Is that the one with the script? Yeah. So just do the same thing, put it in there, and then zero it out.
Cool. Alright, and radius you said?
I think it's fine. I mean, you could keep tweaking it, but
Yeah. Alright, cool. So let's check this out. Actually.
yeah. So the last thing to make this effect look even cooler, right, is I want you to create a light. So go to Game Object, Light, Point Light, to make one of these little lamps. Do the same thing with the lamp, kind of put it in the object, and then I'll tweak the color of the lamp, make it like orange. And the intensity, you can make it like 3 or something. Okay? And the same thing, just parent it to it, and voila. Now you have it really looking like that. Like, check out how mine looks now. See that?
Yeah.
So it's really affecting it, the environment. happy with that?
What does F do when you hit?
Just zooms you to the object.
Oh, okay.
You can really see the normal map now on my game view. Do you see that? You see how it's affecting over there?
It's affecting, on the wall, yeah.
Yeah.
Yeah. Cool.
Yeah, so that's all because of that normal map.
It's really awesome.
Right. Cool.